Hello and welcome RCSchim in the hangar. Today you will see the contents of this black box, which happens to be an Aaronia Spectran V6 RSA500x, which happens to be world's fastest USB spectrum analyzer for RF measurements. I have a lot of curiosity on this field of RF measurements. My background is on the one side IT, I'm a computer guy, and on the other side I'm an avid FPVer since now more than 10 years. And with FPV you always want to have the best signal, you want to understand antennas and RF in general. And since I'm curious, I want to measure stuff. Didn't take long until I wanted to see the first RF waves somehow visualized. The first thing I got like ages ago was this rather cheap RF Explorer, which is a handy device for the hobby grade enthusiast. It's somewhere between $200 and $300. It's not a lot of range that you can scan, but for what it's worth, it is quite nice. This is not a device for the hobby grade market. You have to be very enthusiastic to spend that amount of money. So yes, it's a costly device for our terms. But if you come from a rather professional application, I guess you will really like this and you will consider this. And this, what you can expect from this versus this, should be the content of my video today. So let's dive in and check out what this awesome device can do for us. Aaronia sent me this device for review, but this will not bias me, of course. I will keep it as honest and as brutally honest as possible with this thing. And of course the biggest point of criticism is the price tag. But if you can get past that, I think you will be quite happy with this. So since this thing has no display and just a few USB ports and antenna ports, you really need a good laptop or desktop PC with the software that comes with it, RTS Pro, which is very, very powerful, but you need to plan some time to get into the software. The software is not 100% bug-free, so there are some things you need to know or learn about to use it right. But man, if you use it the right way, you can see so much more. And I compare it to the already quite good software that comes with this thing here, the MCS software. But in comparison, it's a really huge step up. So the V6, the V4 and the old RF Explorer. As simple and stupid as it is, it always was quite easy for me to get nice results here in its limited capabilities. The center frequency is at 2410 with a span of 85. The V6 is also centered at 2410 with 85 span. It gives you those two spikes here, which are from my wireless microphone, and this is just wireless LAN. But of course here you see it in much more detail, like 2410 with 85 span. I don't see a lot here, but I can connect this to the computer. And I've set both spectrum analyzers to the same frequencies, and look at the difference that we get here. This is just in real time. It's 26.7 microseconds. That's very, very, very fast. This in comparison, you even see how slow it builds one screen. To see this spike better, we need to zoom in and take a span of like 10 megahertz. That's 2403. And now we see the spike in the middle. Yeah, almost. It's nice. Different colors, different objects. I guess you've seen why I'm so excited for this one here, of course. Very, very accurate. So the major part of my review today will not be showing this, it will rather be showing you the computer screen, because there's where the magic happens. Before we jump over to the laptop, let's take a closer look on just the physicality of this thing, and then we take a look at the software. So this is the device. It feels heavy, but it's only like 800 grams. It's a full aluminum unibody design. You can open it up, but you have to also open or tear away this sticker, and then it doesn't stick anymore, so don't bother opening it up. It looks very well put together in the insides. This metal, aluminum, I guess. The little fan that's active if you're really demanding a lot from the units. And on the other section here, I guess this is the computer chips, and this is more the RF part, because here are the RF connectors and the RF magic. Just note that it's very rugged, feels very, very high quality. So on this side here we have 2 RX and 1 TX. I applied those red dust caps myself. Note that the version I have here only has 1 active RX, the second doesn't do anything. I understood that it's only a licensing issue, so the hardware is built in there. But note, if you wanna have 2 RX at the same time, you need to buy the larger license. And the TX, you can generate signals. You can record signals here and play them back here. And on the other side, we have reference, trigger, PPM and GPS. This is for the more advanced applications. But the things that I needed was 2 USB ports for the data and 1 for power. And about the data, these should be USB 3.1 ports on your laptop, or else you will not have enough power. They should be at least USB 3 ports, so that you can transfer enough speed over your USB port. And for the really large bandwidth, you need both USB ports, but it's only in like 245 megahertz mode. But that's too much of a detail. So here you have the USB ports and juicy cables, and here you have the antenna ports. And it's stackable, so you see these little holes for screws there, and some dents here. There is a power bank in the same form factor that you can apply, or you can just apply or use more devices at once and have a larger area of RF measurements that you can do at the same time. Then, of course, you also get a little power supply, USB-C power supply, which it's not enough to have your own little power supply. It needs to supply a lot of volts and watts, 30 watts. And this is the first thing. If you want to use this on the road, you need a really powerful power bank, also in terms of watts it can deliver. So rather buy an expensive power supply or the power supply that they give you, or just check the specs of the power supply you plan to use. I had no luck with all the power banks that I currently own. This is one of their antennas. This came actually with the older device. This is a Hyperlock 7060. This is suitable for a very large bandwidth or region of interest. So it goes from 300 megahertz up to 6 gigahertz quite accurately. This little screwy thing, so very high quality also on the USB cables. The red one is the power, and then you get 2 of those black ones, which are the data cables. So let's connect this device. Power to power, that's easy. As I understood, on the 120 megahertz version you only need 1 cable, you don't need the boost cable. The boost cable is only if you have the 245 megahertz version. So now I've connected this Hyperlock antenna. This is the software. Then I played around a lot with the profiles, because there were way too many profiles for my needs. I'll show you, of course, what profiles are in a sec. And I have some missions. Missions are kind of the settings for your measurement. Make sure you use the proper USB 3 ports on your laptop. Especially on older laptops, you might have USB 3 and USB 2 in the mix. So get the USB 3. So it's like most programs, you have menu bars and ribbon bars with a lot of settings here. There is the configuration pane, and this is our main screen where we see the spectrum. Now currently we don't see anything, nothing's moving here, no fancy graphics, because we didn't even turn on the Spectran V6. So as soon as I turn it on, these LEDs shouldn't be red anywhere. If power is red, you need to supply more power. Also, if your data or boost cables are red, then you might have used an USB 2 instead of USB 3 port. So this is how it should look like. I'm using the receiver channel 1. And if I hit play there, it actually uses, but it doesn't show us anything because it's the device I'm using. But the sweep zoom is the program block that's used. Yeah, the whole software is built using blocks, so you can reconfigure quite a lot. Maybe we come to this later. So if I hit start here in the sweep zoom, now it begins to show us something. This sweep zoom I got here, and I have all the missions that I made or that I got from Aaronia as download in the description of this video, so check this out. When I move around my mouse, you see the cursor to also read the megahertz quite exactly. This is the spectrum here, the green line. Turn on the maximum hold function. You see the maximum values there. It's quite small now. So we can, with the scroll wheel on the mouse, I can increase the axes here, the values, or scale it up so I see more. The most important thing first, I mean, my scan here starts at 75 megahertz, you see it here, and ends at 6 gigahertz, so that's the whole range. And if you ever use the spectrum analyzer, an RF spectrum analyzer, you know that normally you cannot look at all the spectrum whilst it still being fluid. Normally it's just a screen shower giving you a full picture in like 10 or 20 seconds. So that's the reason why we call this world's fastest USB spectrum analyzer, for a reason. And we are not even in the full speed. So we're in the lowest speed that we can be. We have only half span. Let's increase this to full span. You see it now moves faster. And the IQ rate, the sampling rate, I call it the sampling rate, is 92 megahertz in one time frame. And if you get the proper license, so this is a software thing, you can go up to 245 megahertz. So we stay at 92 megahertz, and if you take a look here, currently we scan at a rate of around 250 gigahertz per second. So since we only scan roughly 6 gigahertz, we are quite fast in scanning a whole screen. 24 milliseconds, point of intercept. So if I increase it to 122 megahertz, and then you have to go to full span again. Now we are at around 350 gigahertz, down to 17 milliseconds. And the fastest setting, 245. And this is where you really need two USB cables, because it's such a massive amount of data that has to be transferred. Go to full span. So this is now the fastest setting, world's fastest USB. 700 to 800 gigahertz per second, 7 nanoseconds. So how many gigahertz per second we scan is also defined by the radio bandwidth. So this is the detail. So 1 pixel here on this scale is 140 kilohertz. So this also depends on the speed of your computer, of course. Maybe let's just, so this blue thing here is called the waterfall diagram because it shows you the RF power over the time, not over a lot of time here. Just disable it, and now we have, yeah, it's much more pleasing for my eyes to be there. With drag and drop I can move what I see, so I don't see too much of the noise floor. I've seen higher values, but anyways, around 800 gigahertz is amazingly fast. Reference value, it's like a cutoff frequency, so you can get stuff out of the noise floor by looking. Yeah, that's another thing, of course, of this device. It's incredibly sensitive radio measurements. Like currently we are at minus 108 decibel. We see a lot of the other noise that's going on. This here is, yeah, what is what? So you see from 75 to 6 gigahertz, you see, currently you see everything, and you see it better if you have the maximum X here, you can reset it. Now, with all those red hills, what do they tell us? They tell us on which frequency we see traffic, more or less. These specific frequencies, they are given to specific companies or services, and this is normally quite well defined in your country. So the frequencies are even sold for an incredible amount of monies to the mobile phone companies, for example. So I know that around 800 megahertz is where my phone receives and transmits. This is Wi-Fi, traditional Wi-Fi on the 2.4 gigahertz band. 5.7 is where the newer Wi-Fi is, the 5 gigahertz Wi-Fi, or our digital video transmission in FPV. So, but if you don't know what is what, then there's something really cool that's called frequency profile, and hit select. I go to multi-selection, so you can select a lot of them. Yeah, and these are the profiles that I was talking initially. These are the profiles that I like and I use, because default values here are a lot and they are not named correctly all the time for my taste. So I played around with this and came up with this. Download this and you will really like it. For example, here in the RC models, I added TBS Crossfire 868 is what I use. And if I click this here, it gives me a blue bar here. If I zoom in, it even labels it, and it's corresponding to where I measured TBS Crossfire to be, which is 860 all the way up to 886. I now always turn off my phone when I fly with Crossfire. Our radio stations are all the way at the beginning. Mobile radio, as I said, 800 megahertz, and GSM 900 is well used here. In Wi-Fi there are so many standards, that's why it's a bit of a mess. Yeah, and you can also just click such a caption and then it just focuses on this. Now suddenly we know what's going on there. This is mobile phones, this and this. So mobile phones apparently are the widest use in frequency spectrums. We can focus on something starting at 75, ending at 200 megahertz. Let's try to be as specific as possible. What I see is really accurately where my radio stations are and what they do. Now let's zoom in there. That's our most popular OE3. The red bars define it, the maximum values define it quite well. Oh. This is where OE3 is receivable for me. Starting at 87 to 90 megahertz with only one range. And as we look there so closely, we can see the radio waves almost. There is a function that you can also demodulate or interpret radio waves, but I still have to play around with it, and it is maybe content for another video. So since we see our stuff so well now, I want to make one additional test. What I do now is I just fire up the DJI transmitter and see where it talks. I think I don't see anywhere of it talking. Now I've also turned on, you probably heard it, I've also turned on the DJI drone itself. And they need to speak to each other. For this to make sense, we also need to turn on the FPV goggles. We just move the reference level and make a lot of the other things shut up. The new DJI FPV drone is roughly neighboring the channel 2 of their older system. This is roughly 40 MHz bandwidth that we are using now. And in the options of the goggles you can use 20 MHz. This is now roughly 20 MHz. Sexy. And it's on channel 5. And we can also go to 10 MHz if we need to for some reason. And the 10 MHz setting is right on the public channel. That's maybe not so nice. Depending on the bandwidth, you get 3 channels, or in the 40 MHz only 2 channels. This is their channel 1, channel 2 and channel 3. They're quite close to each other. And in the 40 MHz mode, this is channel 1 and this is channel 2. Yeah, nice. Now I jumped with the drone to the 2.4 GHz mode and you immediately see that we are here and we are what? Once again the 40 MHz mode. I unplug the goggles. Now the drone looks at the beginning of 2.4 GHz. And now it's swapped to, do you see it? Now it's swapped to the public channel in the 5.8 GHz mode. It stays there until it gets the goggles again. Now I plug in the goggles. The goggles boot up and just take a bit of time. And now it shows the 5.8 GHz band. And it will probably stay there. And it's using quite low power because it's so close to the drone, and it will increase the power levels if it flies further away. This is the Spectran in real-time speed, looking quite closely to a Crossfire signal, TBS Tango 2, which is on 868. And you see frequency hopping in action really fast. Okay, a little test of the pulsed waterfall and the pulsed waterfall in 3D. I see my pattern that is very easy to see are those 4 dots. They are also here. And if we measure from this point to this point's center is 1 Hertz. Knowing it is 1 Hertz, if I set the duration to 1 second for the whole display, I see kind of the repeating pattern behind the channel hopping that Crossfire does. So from above it looks a bit like a sine wave, but not really. Yeah. I wonder if Trappy would recognize those things, if he ever saw it in that manner. If you just have some questions, leave them in the comments and I will come back to you. If you have stuff that you want to be analyzed, go ahead, send it over to me either via email or just in comments of the videos or on Facebook. I understand this. It's pretty unique that some of the FPV guys in our hobby has access to such devices. And I want to make this device accessible for you as well. So if you have anything to measure, don't hesitate to contact me with your ideas. I will try my best to make a video about it. And they also asked me, please, if we send you such an expensive device, please show it every now and then in your videos so we get some advertisement, and it's only fair to do this for them. So this is a device ready for the community. We can now measure the things that we are curious about, and I do my best to help you with this and also create some nice juicy content with it.